Hi, my name is Randy Graham. I'm the Deputy Chief of the Science and Technology Integration Division for the National Weather Service Central Region Headquarters. Today I'm going to be talking about what we're doing to evolve the National Weather Service to more probabilistic, ensemble-based forecasting services. You can see my co-authors listed on the screen, and I would especially like to acknowledge Sherry Wiedenfeld, who is the Information Technology Officer at the Milwaukee office. So as an overview, we'll discuss why we need to evolve. We'll look at the Central Region Probabilistic Data Infusion Plan, and we'll spend the majority of our time talking about the 5 components of that plan. So why do we need to evolve? Forecasters have traditionally relied on deterministic model output and our understanding of storm scale, mesoscale, and synoptic scale meteorology to create forecasts in addition to looking at observations and current trends. However, now we're really transitioning to more probabilistic science and better use of ensembles. We think about things like the national blend of models, or increased use of ensembles. And so this is really going to be an evolution. We need to really understand how we're going to interpret and communicate this probabilistic output. So we're really trying to evolve away from looking at a bunch of deterministic models and kind of playing model of the day, which we're really not very good at, quite frankly. So looking at the full distribution of the potential outcomes and looking at probabilistic output to make best forecasts and provide the best information to our public and partners. In fact, in the EC NWF User's Guide, they talk about how it's best to be a meteorologist in days 1 and 2, but it's almost better to be a statistician beyond that, as you need to understand ensembles and probabilistic output. In the Central Region Weather Ready Nation Roadmap, we have a milestone that was to develop a plan to facilitate infusion of probabilistic data into forecast operations. And that is where we came up with the Probabilistic Data Infusion Plan. The plan has 5 parts: foundational probabilistic training, probabilistic ensemble tools resource page, a probabilistic messaging test bed, probabilistic and ensemble tool vignettes, and finally a forecast search wizard tracking terms in our AFDs. First, we'll look at the foundational probabilistic training. This is being developed by the National Weather Service OCLO, and they're working with SMEs across the agency on approximately 15 modules, which will be available in February of 2021. The vignettes are going to cover a variety of probabilistic techniques such as neighborhood probabilities, fuzzy clustering, and the vignettes are all going to be like 3 to 5 minutes long, and they're going to be really focused on ensuring that we all have a basic understanding of the statistical approaches utilized to create these probabilistic tools and output. So what we did in Central Region was we made sure that everybody in the region is going to take them. All these modules have been assigned what we have called a regional training memorandum. So all forecasters will get this foundational training this year. Then additional thrust areas will be on application and communication of probabilistic output, should be available from OCLO in late calendar year 21. So that's the first component. The second component was a probabilistic ensemble tool site. We had an STI AOP item to create a resource page consisting of data archive sites, which we won't talk about today, and ensemble tools and probabilistic forecast information. We wanted to include links to resources, but not just links. We also wanted to provide descriptions and also links to pertinent training material and background material. So here's what you'll see if you go to our site. This is the front page, and you can see across the top it has links to the different subsets of ensemble and probabilistic tools: situational awareness tables, mesoscale ensemble viewers, national blend of models, etc. And down below you can see little snapshot images of the different tools. This, of course, isn't all of them, and all the web pages you can visit. So if you click on one of these links across the top row, such as situational awareness tables, they'll take you to a page with more details. And so here you can see the ensemble situational awareness table for the NACE is the first one. The second one is the same, but for the EC NWF. And there's a description in the middle about what's available on the site to give you a little background. And then on the right, you have links to pertinent training, links to background resources, etc. Another example is you go to the ensemble plumes and point data. Here you would find the guest plume viewer and the what's up point viewer and associated resources. And so every one of these links will take you to a subset and hopefully provide a little background information as a way to organize these sites so that everybody doesn't save a bunch of bookmarks. So it's kind of a clearinghouse where we can take sites off as they deprecate, add new ones as they come along. Here's a national blend of model sites with the new resources that are coming on all the time, leveraging the NBM. So you can find this site, and the link here is the Central Region Science and Technology Integration site. Under the Science and Operations tab, I have highlighted in yellow here Ensemble and Probabilistic Guidance Tools, and you can access these resources. So that's the second part of the infusion plan. third, and maybe the most ambitious, is the probabilistic messaging testbed. And you can see there are 9 offices participating in the testbed, stretching from the northern and central plains into the Great Lakes. And these offices are really embarking on not just collaborating on the forecast, but collaborating on the messaging strategy for the forecast. It's a little different approach. They're going to have access to new tools and graphics. They're going to be creating probabilistic snowfall maps. When you create maps, you're going to have flexible percentile ranges. So not just the 10th and 90th, you could also choose to use the 25th to 75th. They'll have imagery based on the probability of exceedance for wind chill and wind gusts. The mean, earliest, latest onset and cessation displays from the Ensemble. This is from a Jetty project being led by Julie DeMuth. Graphics for probabilistic snowfall rates, probably the precipitation type from the NVM, that sort of thing. If you want to learn more about this messaging testbed, please see Phil Schumacher's presentation incorporating probabilistic information into winter storm services. So we're kind of looking at the messaging strategy that they're going to be talking about, these 9 WFOs, is kind of like a messaging funnel, just like we talked about the forecast funnel. And as you get closer, more and more confident, your messaging strategy, of course, changes. So when your confidence is low, like less than 30%, you might be just doing it, it's like an outlook. So you're just raising awareness. And then when you get to a little bit increased confidence, 30 to 50%, you increase your IDSS. You're maybe doing probability of exceedance graphics. Maybe providing some snowfall ranges. When you get to the watch level, 50 to 80%, you're definitely going to be providing some probability-based ranges. And WFOs will collaborate on what are those ranges based on. Are they 25th to 75th percentile or the 10th to 90th? And that's the kind of thing they're going to discuss in their messaging strategy. And then finally, when you get to the warning type confidence greater than 80%, then you're getting into more deterministic information, although you still may be doing probability-based for mesoscale phenomena. One of the tools we're using to help offices, or one of the ways they're communicating, is probabilistic messaging testbed dashboard. And on the bottom, I've highlighted in blue here, there's 5 categories. They can shoot no impactful weather. Yellow is just broad brush maps or text only. Orange is potential probability of exceedance type graphics. And this way you know what your office and neighboring offices are planning on doing during the day. And so at the top, you can see, like in the first row, Aberdeen says they're using probability-based accumulation ranges there in red. And they're using the 25th to 75th percentile for their storm total snowfall range. And you can see other offices are basically doing the same thing. And this is a way that they can communicate what they plan on doing, and they can add additional details and rationale on the far right. So here's an example, maybe in the extended range, you're less than 30% confident. And so it's a very, just kind of a broad brush graphic, accumulating snow possible this weekend. There's a lot of uncertainty when, where, and how much snow will fall, and that sort of thing. But offices would know that they're all on the same page within reason when they're communicating how they're going to message the event. And obviously, not every office is going to be in the same status across the test bed, because you might be far more confident at one point in time on the western edge of that test bed than you are on the east, but there should be a nice distribution and continuity across that area and a smooth transition if you're going in different directions. So here's an example, maybe where you get to the 30 to 50% confidence and you're doing potential snow amounts graphic, or probability of exceeding 2 inches. On the right, you'll see. But if we look at the left graphic there, the potential snow amounts, you might notice that there's some non-traditional snowfall ranges, like 0 to 3 inches, 1 to 4 inches, trace to 3. And that's because we're allowing probabilistic output to drive snowfall ranges, and we're not sticking to traditional ranges like 2 to 4, 4 to 8, 6 to 10, etc. The PDF is driving what the snowfall ranges are. What the forecasters are choosing is, do I use the 25th to 75th, 10th to 90th, etc. Another example is the risk of wind chills below -20 degrees or -50 degrees, like in this example. We'll just kind of focus on the left graphic here with the risk of wind chills below -20. And one thing we've learned from social science is when you use categories like low, moderate, high, like we have here, it's more effective, or most effective, if you include a percentage with that. In this case, look at the high category. All those numbers in that area are 75% or greater. And that provides not just a category, but also a percentage that people can relate to. And then finally, when you maybe get into like the watch area and you have a large PDF, a big spread in your potential snowfall ranges and your 10th to 90th percentile images on your website, then you might be communicating the different scenarios. Hey, the middle one's the most likely scenario. This is what we think is most likely. However, the reason you see this big range is in scenario 1, it's more wintry mix or rain. That's why we might have less snow. And in scenario 3, this is where you get high numbers. And so it's about communicating why the range is so large. So that's the probabilistic messaging test bed. Again, please see Phil Schumacher's presentation for more on that. The fourth aspect is the probabilistic ensemble tool vignettes. We have approximately 12 regional SMEs involved in this effort. We're going to be creating 5-minute vignettes on a lot of the material that we see in the foundational probabilistic training that I mentioned earlier, neighborhood probabilities, probability matched mean, percentiles, how to use situational awareness tables, et cetera, NBM standard deviation plots. What we're going to be doing is trying to look at these real-time events and provide kind of just-in-time examples that are short and to the point, talk about foundational knowledge, how you would use it and interpret it, how you would describe it in an AFD, and then how you might communicate it to the partners in public. And we're going to try to be doing these every few weeks, basically, so that we're continually thinking about these concepts and then trying to apply it in real time. An example would be, the vignette concept would be one like the neighborhood probability example here. So we would take the review of the concept from the foundational training material from OCLO and just do a quick refresher on that. Then we might go, hey, let's look at some href output from this event and look at the individual runs and then say, here's what comes out of the neighborhood probabilities, in this case, for 2 to 5 kilometer updraft helicity. And here's maybe an area where your tornado threat is greatest. And then we talk about how you might describe this in an AFD. href output indicates that there is a region within this risk area that looks more supportive of tornadoes, and then talk specifically about the probabilities of maximum updraft helicity greater than 75 meters squared per second squared, et cetera, and just provide an example of how you might use it. And then, of course, do a quick review of what actually happened in the event. So these are the vignettes. We're going to be trying to do these every few weeks. The last portion of the plan is the forecast search wizard, which we're using to search our AFDs, which was originally developed by Eric Allen at the University of Delaware. It was modified for this project by Andy Just. So we're using keyword searches such as ensemble, NAIFs, percentiles, href, et cetera, to see how we're evolving in our thought process and moving away from deterministic use of things like the NAM, the GFS, and the EC model, and looking more to NBM, percentiles, ensembles, and that sort of thing, probabilistic terms. And it's just a way to track by region, by the whole weather service, by office, our changes over time. And you can see just a quick example from Andy's work here, the term use of the term NBM and the massive increase in the red line from 2018 to 2019 when we started really initializing more and more with the NBM. So we're just going to track this over time to see how we're doing. And to learn more about this, see Eric and Andy's presentation utilizing the forecast search wizard to investigate usage of ensembles and probabilistic data in the National Weather Service. And that is all I have today. Here is a summary slide. Thanks for watching. I hope you joined to ask any questions. You can see my email at the bottom of the slide there if you want to share anything or have any questions you want to share, send me offline. Again, thanks very much for listening and take care.